Hi, I'm Michael DeSando. I'm an applications engineer intern in PPD, and my project is a battery management system. It features 3 to 6 series cell support for all lithium-ion chemistries with a cell voltage range of 1 to 4.5 volts with a supply voltage of 7 to 36 volts. It features overvoltage protection, undervoltage protection, overtemperature protection, and automatic cell balancing using programmable thresholds. I created the code for my BMS applications, which include cell voltage, pack voltage, pack temperature, state of charge, and automatic cell balancing. The first part of this project is the battery pack, which consists of 6 lithium-ion cells in series. This project can support all lithium-ion chemistries, but for this particular project, I'm using 6 Panasonic 18650s with a nominal voltage of 3.6 volts. The cells can be anywhere from 1 to 4.5 volts, and the reason you need 3 is because the battery pack powers the BQ76PL536 Evaluation Module, so it requires at least a input voltage of 7.2 volts, which is approximately 3 cells, and no more than 6 cells because the absolute max for the evaluation module is 36 volts. The negative of the first cell is connected to P7 of the evaluation module, with the negative of the next cell connected to P6, with the next negative cell connected to P5, and so on until the positive of the 6th cell is connected to P1. Notice that the evaluation module has 3 BMS chips, which means there are 3 ports, so you can have up to 3 battery packs. But this project, I only use 1 BMS chip and 1 battery pack. The evaluation module has 3 BQ76PL536 BMS chips, which have ADCs, which allow for measuring the cell voltage, pack voltage, and pack temperature. The ADC features plus or minus 3 millivolts of typical accuracy, 14-bit resolution with a 6 microsecond conversion time. The cell balancing is taken care of by this circuitry here, which includes external MOSFETs and power resistors. The ADC takes measurements of the cells and then outputs bits to the gates of the MOSFETs, switching them on and off as needed to balance the cells. The evaluation module also has 2 digital isolators, which prevent the input supply voltage from being outputted onto whatever is connected to here, whether it be your computer or your microcontroller. This port right here, P5, is the SPI communication port, which I have connected to my microcontroller. Port J4 also has 4 pins that can be utilized in code, which include a data ready, a conversion bit, and a fault and a alert pin, which are set if cell overvoltage or cell undervoltage or overtemperature is detected. For my microcontroller, I use a MSP430FR5969 with a Sharp LCD BoosterPack with capacitive touch sliders. I have one of the sliders disabled because there wasn't enough pins for both sliders and the BMS SPI. So I only have one capacitive touch slider enabled, and then I rewired the 2 buttons that come stock on the microcontroller to be on the front panel of my BMS case. So that's my project. This is a demonstration of my battery management system. It starts with a 5-volt 2-amp power adapter. Plug it in. It gives you an error message when the battery pack's not connected, because the BMS chips are powered by the battery pack itself. So when I plug the battery pack in, it brings you to the main menu. These are the apps I wrote in code. The cell voltage gives you the voltage of each of the 6 individual cells. The voltage is displayed in millivolts and then returns back to the cell selection screen. The exit button brings you back to the main menu. Pack voltage gives you the overall pack voltage in millivolts. The state of charge gives you approximate amount of charge for each of the individual cells. The temperature gives you 2 different temperature readings, which are from temperature sensors in the battery pack. And the cell balancing feature right now only lets you know that the cells are imbalanced. The actual cell balancing itself is commented out in code due to code size limitations from the free version of Code Composer Studio. The threshold is set for 50 millivolts, but this can be programmed in code. And there's also a cell balance timer, so when you click to enable cell balancing, the cells will balance for the specific amount of time set by the timer, and then it will check again to see if the cells are imbalanced or not. And this again can be changed in code.